Good evening, gentlemen. A warm welcome to today's presentation on the subject of health, safety and environmental regulations for industry. Our guest speaker today is Dr. Stephen Pathmarajah from the UK. And today's presentation is jointly organized by the Institution of Mechanical Engineers Sri Lanka branch and the sectional committees of the Institution of Engineers in Sri Lanka, that's the Mechanical Engineering Sectional Committee, the Chemical Engineering Sectional Committee and the Agriculture and Plantation Engineering Sectional Committee. The guest speaker, Dr. Stephen Pathmarajah, has a very extensive CV, but I will try my best to make it as brief as possible, and I beg the apologize to the guest speaker if I have mutilated part of his CV. Dr. Stephen Pathmarajah has a BSc Honours in Mechanical Engineering from the Middlesex University. He has also a MSc in Thermodynamics and Fluid Mechanics from the City University in London. He also has an MSc in Electrical and Electronic Engineering from MUST University in the United States of America, and he also has a PhD in Engineering from the University of Warwick in Coventry. His employment history is quite exhaustive, and he has served in many positions in the UK. Starting from 1978, he has been a designs engineer in the high pressure manufacture of boilers in Peterborough, UK, from 78 to 80. From 80 to 87, he has been the R&D manager also in the UK for a company called Hartley and Sugden Limited, who are manufacturers of industrial boilers in Halifax, United Kingdom. From 87 to 88, he has been senior design engineer for Hopkins Valves, also now known as Weir Valves, in Huddersfield, UK. He has subsequently worked as principal consultant to the business manager for the institution known as the UK Atomic Energy Authority in Warrington, UK. He has also been senior project engineer at Castle Cement Limited, a manufacturer of cement and cement products in the UK. He has also been, from 2008 to 2009, served as technical manager in Albania for a cement manufacturing concern, and he is also the owner of a consultancy company named McLellan and Associates, which he still operates in the UK. He has also been working in Yemen for considerable amount of time, and I would say that his coverage worldwide has been quite exhaustive. He has also published many reports and papers over a period of time starting from 1978, and his key skills and competencies are listed as project management, negotiation skills, commissioning of plant and equipment in a wide spectrum of industries covering power generation, nuclear power plants, cement plants, and also he takes great pleasure in finding solutions to complex problems. So he's a bit of a troubleshooter. Because anytime you give him a loaded question, he always has an answer for it. And he has tremendous exposure to the health and safety and environmental aspects of industry, and also involving risk assessment. His leadership skills and motivational skills are also quite good, and I have had good examples of some of his motivational skills. So I give you Dr. Stephen Pathmarajah, who will talk to you on health, safety and environmental regulations in industry, for industry. Thank you.
Thank you. You are not able to people in England, everybody is there. That's why I decided to walk around. So I'll come get you if you don't want to know. As I said, my name is Stephen Pathmanathan. I did my A-level here. Can you all hear me? Okay. Yeah, I decided I'm 250. But I don't want people to get excited, so I'll stay here.
No, that's right. Life
Image is not going.
image is not. There is a light coverage.
Yeah. I know, do you want me to do that?
No.
Because
you are
Because I able to follow this lecture from elsewhere, plus it can be transmitted subsequently.
okay. Can you hear me now? Okay, good. So, I was born in Sri Lanka. I went to school in Jaffna, did A-level, but I did not get the right grade. I was offered a university degree to do maths. I wanted to do engineering, so I went to UK. So you people are engineers in Sri Lanka, you are cleverer than me. So don't give me a hard time, please. Okay, agenda for today is simple. What I want to talk to you about is, do we as engineers need health and safety environmental regulations? And also talk about origin of health and safety, particularly related to the UK. The type of regulations and heart of the matter of HSE, health and safety regulations, mainly concentrating in the UK. I want to give you some examples, then summarize it. Any question? I have no intention of speaking long time, so you can ask me anything you like, but I have the privilege to tell you I don't know the answer. Okay? That is the logo for the health and safety regulators in the UK, or we all call it HSE. What HSE do is, although they are the regulators, they do not want to prosecute the engineers or the factory. They feel passionately to help and work together. They feel as a regulator, if they take us to court, they have failed. So their objective is to achieve better standard rather than prosecute. Now, let us consider the concept of regulation. Can anybody tell me what regulation is? Let me tell you. Regulation by definition is to control the activities of some for the benefit of the others. Okay? So, sooner we talk about controlling the benefit, or controlling the activities of some, that some people feel it is bad they are controlling it. Is it true? And is HSE regulation any different? I need this font. We can use regulations in two aspects. Before I go there, let me tell you, if we have no regulation, nothing in the world will work. Apart from the two people, everybody here drives on the left-hand side. If there's no regulation forcing us to drive on the left-hand side, we can never go anywhere. Everybody will be driving everywhere. Similarly, you all heard about the Robinson Crusoe story. It was a true story. He was a very naughty seaman, so they kicked him out. So he went to the island. The first thing he did was self-regulate. He set some regulation how we're going to live. So we all need regulation. Without regulation, nothing will work. So, in reality, we can look at the glass of beer, half full or half, we can complain it is half empty all the time, or we can say it's half full and be happy. On the face of it, we don't like regulations, but without any regulation, we cannot work. Just think about it. When you get married, you set up regulations, honey-do list, homework from wife. So we have regulations all the time. So regulations everywhere. Let us see some example. As I told you, we regulate ourselves. We cannot live without it. Nothing will work. We need it badly. Question is, how does the UK regulation differ? Is there any difference between UK regulations and other regulations? First, look at an example. I want to give you an example. I hope you can see this one. You can see this real situation. When I was in Jaffna, I used to carry things like that. Okay? Now, the UK regulation says, the EU regulation says, there's a limit of maximum of 25 kilograms. Okay? That benefited a lot of people. But there's also a misuse. Can anybody tell me what the misuse was? Misuse was very simple. Because there's no sex discrimination. So the women are employed on equal basis. So the company says, you are equal basis, carry this 25 kilo. And disabled people carry the 25 kilo. There's no discrimination for age. So I can work as long as I can properly work. So it doesn't matter how old it is, take 25 kilo. So the regulator said, no. They stopped this one. How did they stop it? They said the very, very maximum is 25. Afterwards, each company has to do an assessment for each individual what is the maximum capacity they can carry. So when the women are employed in the post office, they carry less weight. That's what assessment says. So what happened is the post office van has lockable cupboard, say they put 10 kilogram there, 10 kilogram there. So they move around there. So that's the way it works. The heart of the matter of health and safety in UK we call duty of care. Okay? First of all, when you are working in any UK industry, we have to display a duty of care for ourselves. I cannot say, okay, no problem, Allah will look after me, I don't need helmet. They say, no, you have a duty of care, you have to wear it. These are the laws. And duty of care if I am a manager, I cannot say to the workers, oh, no ladder, just climb on the wall and fit the light. We cannot do that. So they say, because I have a duty of care to my staff. And we have a duty of care to our fellow workers. And we have to use PPE, personal protective equipment, that is helmet, goggles, gloves, and boots. They are mandatory. You cannot go to any site in UK without it. No flip-flops, no slippers, no sandals allowed. no shorts allowed, no t-shirt allowed. Your overall, fully overall up to here, up to their shoes. What are the key requirements of duty of care? What are the key duty of care requires? Planning the job. Any of you engineers know there are two types of people, engineers. One man says, run up to the place and say, oh, I brought the wrong spanner, I didn't bring the spanner, come back again. And go back and, oh, I didn't bring the spanner, or the spanner wrong size, or go back again. Other people say, no, I'll go later. I'll plan and what the job is, get the toolbox and go. So what they are promoting is a duty of care and efficiency in working is to plan the work, reduce the risk, take the correct equipment and use the correct equipment. In the UK, we are not allowed to use any portable electrical equipment which is more than 110 volts. 240 drills are not allowed. So history of UK, it has always not been like that. Before, when UK was ruling us here, we were ruling here, the safety, health and safety regulation in UK was very, very bad. A lot of people died because they put their hand in the belt and the shaft got killed. A lot of people killed. Then they were sort of fighting with the good people. There are some good people, and the workers said, no, we cannot work like this one. So they improved the safety. When I worked in Yemen, people will say, I don't need this one. Allah will decide when I die, not you. I said, no problem. You go and work in Allah's company, not here. I said, go home. I said, you are working in my company, you wear what I tell you. You don't want to like it, you go and work with Allah. Regulations in the UK evolved in two ways. You will like this. In the European countries, what we call a prescriptive regulation. This all started with Napoleon. He was emperor, but before he was an emperor, he was an army commander. So he did not stand any nonsense. He said, I am right. You will do what I say. Does anybody know why people in the continent drive on the wrong side of the road? Because Napoleon found that his soldiers are fighting, they are riding in the horse. They used to ride like UK on the left. When the other man comes, they took the sword out and cut it. So he said, no, it's causing me problems. So I asked him to ride on this side, other man come on that side. So he couldn't get that way. So he had to turn the horse around and come back. By the time he turned the horse around and come back, other man ran away. So that is why all the continents are on the drive what I call on the wrong side. We here and India drive on the right side, Australia right on the left hand side. But the UK has a different approach. Has anybody heard about King Charles I? King Charles I did not like the parliament and he put tax too much. So the people say, no, you are not a good king. And they tried him and cut his head off. It's simple. So the UK has a goal-setting approach. They give you freedom. They give you general goal and say this is what you achieve. How does it work? Let me see. Most companies love prescriptive regulation. They say, tell me what you want to do. Tell me what you want us to do. One of the job I did when I worked for the business manager was to write a regulatory book, handbook for the regulators. They asked me, paid me money to do it. For the cement factory to reduce emission. All the cement factories case, just Steve, tell me what's the maximum limit we can pollute up to it. Regulator said, no. You should do as much as possible to reduce it. Our job is to tell you to reduce it, use the best technology. And year by year, they need to show they are doing better. But with the prescriptive regulation, when you have a set of prescriptive regulation, when a new technology comes, or new method of production comes, then we have to write a new set of prescriptive regulation. Goal setting approach difficult to comply because they say your injury to people should be less than 1 in a million or 1 in 100,000. Do whatever you want to do, but make sure it's safe. And you make sure. I know you talked about the code of practice. You use the best code of practice. Doesn't matter which one you use the best one. So the regulator will come and say, did you use this one? Why didn't you use that one? So there's always an argument. They have to use the best. But in return, what the Health and Safety Department do, HSE do, is they do a lot of research and produce a lot of guidance book, which are free and free to all the people anywhere in the world. A lot of people use it and make use of it. But with if I have a new technology, HSE man doesn't worry. You can have anything. But this is my goal. Achieve it. Do much as you can to achieve it. So they avoid having to write new regulation every time there's a new technology comes. When you all heard about the tunnel goes from England to France. When they started to build safety, because in the days when Brunel and Stevenson they did tunnels, they killed over 300 people. For them it's not a problem. But here nobody got killed. The reason is they have to have a safety case. French people said, I don't understand your goal setting. They have a safety case from France all the way to Calais, all the way to Dover, based on the prescriptive system. We said, I don't want to do the prescriptive. We have a goal setting regulation this way. So all the English people worked on one regulation, all the French people worked on one regulation. That's what happened. How does the goal setting regulation work? It sets the standard. The way to achieve is up to us. It doesn't mean free for all. There are fundamental requirements. These are based on hierarchy. Now I'm going to enjoy this to you. You are engineers, you have a responsibility. In my book, you are all failing on responsibility. I'll show you in a minute. What they are saying is that if this danger, eliminate it. Don't use it. Then they say, we cannot do that, minimize or reduce. Then contain or protect. Let me look at the hierarchies. Tell me, you are still using asbestos. There's no asbestos in England, none at all. But if you have, then it has to be removed. To remove that, they have to wear the full protective equipment, and it costs a lot of money. And I don't know why you can allow people to have asbestos if you're breathing asbestos. Same as DDT, total elimination. CFC, total elimination. There's no question. They said, don't use it. So we don't use it. At the beginning, everybody said, oh, without asbestos we can't do anything. How can we do the gas case and all the rest of it? We are doing now. CO2. If you are burning fuel, you have to have CO2. End of that. We cannot do much about it. So what they are saying is render harmless and the limit. And dust emission, back filters, emission limit, SOx limit. When you come to radiation and other, we have containment. They said you contain it. If there's any leak in there, you contain it. Don't let it go to the public. And also personal protective equipment. So what's the heart of goal setting? key to complying goal setting is risk assessment. Has anybody done any risk assessment here? Hands up. Has anybody done? Oh, good. At least one of you did it. Okay, so you can shout at me if I say wrong thing. Okay? You will enjoy the next picture. Risk assessment, we have 5 steps. First, ask what can go wrong. We have different set method of assessing that we call, has anybody heard HACCP? Okay, we have a method called HACCP, which is basically testing every aspect of what can go wrong. Question time I can talk to you about HACCP. Then we say how likely it can go wrong. Then how badly it will be should it go wrong. Then does it matter? And what can be done to prevent or minimize? These are the 5 steps. I hope you do it. How does the risk assessment help? If the job is a risky. All it does is to make people think about what are the things which can go wrong and how bad it will be, all the 5 questions. And it makes people to think about the work and do the work safely. Above all, it helps people to make a method statement. In our company, I worked in Castle, every job has a method statement in the risk assessment. Any new job, before they start, they have to have a method statement in the risk assessment. Path loop, I want to talk to you about the path loop. We talked about the goal setting. Path loop was an experiment needed to be done in a nuclear reactor. My job was to review the safety case they produced. They originally started to do 4 half-size fuel elements. Then they ended up in doing 8 full-size fuel elements. So the pressure vessel was made out of zirconium metal because it's going to go into the reactor. And they calculated everything using all the computer calculation, and they said it will be okay to work within 250 degrees. I did a hand calculation. I told them if you have a fault condition, you can go up to 260. The code of practice which Gamini was interviewing about it says maximum for this material is 250. I said the code of practice says 250. If you want to go more than 260, you can go up for 250. We appreciate you are going above the code of practice. Can you justify it? They said they can't. So the project was cancelled. We spent 40 million. So I was put under big pressure to approve it. And I said, no, I can't approve. This is my calculation. Show me where it's wrong. And they couldn't, so they cancelled. Next project. So, transportation of fuel flask. What it is that BNFL is a place who process spent nuclear fuel. They develop a procedure to transport radioactive fuel from one place to other place. In the manual, it says every time the transport tractor is going, they will have a flashlight going warning. One day, the regulator came and he said the fuel truck is going, his flashlight is not working. Why? He said there's no fuel, but you didn't say it in the regulation. They said either you amend the regulation or you accept fault and make the rectification. They argued. Stupid people. I would not have argued. I would have changed the regulation. I'm sorry. They argued. So the regulator said, if you won't argue with me, then we will argue in the court. Finally went to court. And regulators was recommended, and the company was fined because they said, if you are moving, people don't know whether it's fuel or not fueling. And if you have a moving, you must have the lights on, or you must say, when it's empty, you put a different light. So that is the level of self-regulation and the goal setting works. Fukushima, the risk assessment. The people who did the risk assessment said, considering all the risk, you should have the wall more than 15 meters. They said, 10 meters allowed. And had they had 15 meters, water would not have come in. That's a risk assessment. This leads us to the concept of tolerability of risk. Have you ever heard of tolerability of risk? We all tolerate a level of risk. When we cross the road, when we start driving, we take a risk. There's a possibility we may get killed in a car accident. It's not your fault, the tuk-tuk man fault, bus man fault, truck man fault, come and hit you, get killed. So that's a risk. So what you're saying is that it's a religious belief. Everybody have a different level of tolerability of risk. My daughter will not cycle without a helmet. I cycle push bike without a helmet because all the time in Sri Lanka I cycle with no shoes, no slippers, no helmet, and she will not. Her tolerability of risk is higher than mine. Can we set tolerability of risk? We all set our own tolerability of risk. What the regulators, HSE, said was very simple. The tolerability of, because all the public enjoy the benefit of the product that the company produce, you have a responsibility to tolerate a risk. But he said that risk has to be at least 10 times less than what the individual prepared to take. So tolerator said the risk of accident in road is 1 in 10,000. So the industrial accident has to be less than that, at least 10 times less than that. That is the level the HSE regulator says. They say this is the risk you need to do. What we have to do is to demonstrate to them our risk level is low. Now I noticed when I lived here in Sri Lanka, I was one of the people who stepped on the train and said, air coming into the face, and the train comes, you run up into the train and jump in. In England, no train leaves the platform until the door is closed and locked. And the doors only opens when the train comes to a station. Here, I understand the new intercity has locking doors, but the new one, the old one does not. I see still people running in there. Normal working, these people are accepting the tolerability of risk for them. But in the industry, they say, the company says their tolerability of risk is higher, they will not tolerate this. So if anybody going to work in the UK or any companies in the Arabic or African countries, Middle East, owned by UK or American companies, you have to know is this one. Their individual tolerability of risk is lower than ours. Then the society as a whole, the individual risk is lower. The company's tolerability of risk is even lower. So what are they trying to do? Our managing director for the cement factory said to us, I want all my workers to go home with all their fingers and toes. I don't want them to have injured. Because they come here to work doesn't mean they have to get killed or they have to be damaged. So they said, for me, if it's going to take 2 hours more, I'd rather spend 2 hours more than somebody injured, then everybody stop to see his injury, then somebody have to take him to the hospital. That's going to cost me money, more money. We calculated it, serious injury cost the company around 90 million pounds. The investigation by the HSE, and the amount of time job stopped. For example, if you look at the, If the truck falls off, because they were too busy to break the stone, the truck falls off, the truck is damaged, then has to be repaired, and there's an inquiry and a delay, all of them costing money all the time, production lost. So what they say is safety really pays, and they improve their efficiency by implementing good safety. And as I told you, efficiency working is very high. If you plan the work and do it, efficiency is high. Goal setting is also working together. The regulators, because they are giving goal setting, they don't give us free rein. They help us to achieve better regulation. Provide benefits to all. Regulators are there to help, not to prosecute. Regulators provide help. And when you go into the HSE website, you will see how much information they have. Everything they have got. Welding, there's a code of practice. Gas cutting, code of practice. Guillotine, everything there's a code of practice. Sorry. Okay. Summary. In the West and particularly in the Middle East, there exists a very, very shortage of engineers, good engineers who can do. Not those people who sit in the office and sign, but particularly go in the field and get their hands dirty. If you can make it, if I can make it from Jaffna, little boy, carrying the things like that, you can make it. Safety is fundamental. In the UK interviews, they ask you a question about safety. Safety and risk assessment helps you think deeper and think outside the box to see what can go wrong. Use HSE resource. And I suggest you set up your, at least within your SLI engineering, set up your own internal department with, among all the engineers, health and safety. It will improve your safety and improve your efficiency. I guarantee that. Thank you. Any questions?